Welcome to section 2.1, Measures of Center. In this lesson, we'll explore how we can summarize a data set by identifying a typical or central value. We'll talk about three main tools: the mean, the median, and the mode. And most importantly, when to use each one. A measure of center is a single number that gives us a sense of where the bulk of the data lies. The typical value. It doesn't tell us everything, but it gives us a solid starting point. Instead of looking at 100 test scores, we can say the average score was 78. That one number helps us summarize the entire set. But as we'll see, different data sets require different measures of center, especially when outliers or skewed data are involved. The mean or average is probably the most familiar measure of center. To calculate it, you add up all the values and divide by how many values there are. It represents the balance point of a distribution, like where a seesaw would balance if each data point were a weight. The mean is useful for symmetric distributions without extreme values, but it has a weakness. It gets pulled in the direction of outliers. A single unusually high or low value can distort the mean and make it less representative of the typical case. All right, so this graph here is an example of a dot plot. That's exactly what a dot plot graph looks like. The dots on that dot plot are at 2, 5, 6, 9, and 11. If we find the mean, then our mean, and by the way, we're going to introduce that in a minute, the symbol we use for sample mean is X with a bar over it. All we do is add those up. So we're going to go 2 plus 5 plus 6 plus 9 plus 11. And if you add all of those up and then divide by 5, you'll get 33 divided by 5, or 6.6. So this balance point right here that keeps this dot plot level instead of tipping to one side would have to be placed at 6.6. If I place it anywhere else, right, then my dot plot will fall over. Now the median is the middle value when the data are arranged from smallest to largest. If you have an odd number of values, it's the exact middle value. If you have an even number, it's the average of the two middle values. Unlike the mean, the median is not influenced by outliers. It's a much better choice for skewed data or situations where one or two extreme values might otherwise throw off your summary. For example, if you're looking at home prices in an area where one mansion costs 10 times more than the rest, then the median gives a clearer picture of what the typical home is. So on the previous slide, we saw that the values for the dots were at 2, 5, 6, 9, and 11. There are 5 data values, so the one in the middle is the median. Our median, just use M for median, is a 6. Let's compare the mean and the median side by side. In a symmetric distribution, the mean and median are usually very close, even the same. In a skewed right distribution, there are a few very large values. The mean gets pulled upward, making it larger than the median. In a skewed left distribution, the opposite happens. A few small values pull the mean downward. This is why knowing the shape of your distribution is so important. It helps you choose the most accurate measure of center. So, for the data from the dot plot we were working on, we saw that the median, 6, was lower than the mean, 6.6. If the median's lower than the mean, that tells us how our skew is. The mode is the most frequently occurring value in your data set. It works for both quantitative and categorical data. For example, if you ask people their favorite coffee size, and most people said medium, then medium is the mode. In a histogram, the mode appears as the tallest bar, the interval with the most values. Some distributions have more than one mode. If two peaks appear, it's called bimodal, and that might indicate your data comes from two different groups. Mode is especially useful when the most common item matters more than the average. For the dot plot example we've been looking at, our data values were 2, 5, 6, 9, and 11, right? Nothing repeated. In that case, there would be no mode. However, if we had had another 9 there, then we would have 2 instances of 9, so 9 would be the mode. So when should we use the mean? When should we use the median? And when does the mode matter? Let's look at some examples from everyday life and make the differences more concrete. We're going to use the mean when the data is symmetric and clean. Think about something like average fuel efficiency for cars in a rental fleet. If all the vehicles are fairly similar and there are no extreme outliers, like a random dump truck being thrown into the mix, the mean gives you a good, balanced sense of typical fuel economy. In that case, mean is useful. We're going to use the median when the data is skewed or has outliers. A great example is home prices. Imagine one neighborhood where most homes cost between $200,000 and $300,000. But there's one mansion that sells for $3 million. If we calculated the mean home price, that mansion would pull the average way up and make it seem like the neighborhood is more expensive than it actually is. But the median home price, the price in the middle, is not affected by the mansion. It tells a clearer story about what a typical home buyer might pay. That's why real estate sites almost always report median home price, not the mean. Now, we're going to use the mode when the most common value is important. Suppose a shoe store wants to restock. They've tracked sales over the past month and now need to decide which shoe size to order most. In this case, they don't care about the average or the middle. They want to know which shoe size is sold the most. That's the mode. If size 9 was a top seller, that's the mode, and that's what they should order more of. All right, so remember, use the mean for balanced, symmetric data, the median when you want a stable summary that ignores outliers, and the mode when the most popular item is what matters. Now, in this table, we've summarized the symbols that are commonly used. The sample mean is written as X bar. It's the average of the sample. For example, the average score from a class of 30 students. The population mean is written as the Greek letter mu. That's the average of an entire population, like the average GPA of all college students in the country. We often can't know mu exactly, so we use X bar to estimate it. The median and mode don't have formal symbols in most cases. You might occasionally see X tilde or an M used for the median in textbooks, but usually we just refer to it by name. Now, let's look at this formula that's here for the sample mean. That big symbol in the numerator there is the Greek letter sigma. It means sum. It's a shorthand for add everything up. The little x with a subscript of the I, that we would read that as x sub I, means the ith value in the data set. So x1 is the first value, x2 is the second value, and so on. N is the total number of values in the sample. So this formula is saying add up all the values from x1 to xn and then divide by how many values there are. If you've calculated an average before, this is just a formal way of writing it. But it's important that you understand the notation because you'll see this structure repeated in other formulas we'll use later in the course. So to recap, X bar is your sample average. Mu is the population average. The symbol sigma just means add them all up. Getting comfortable with this notation now will make everything that follows, from variability to inference, much more approachable. All right, now let's practice calculating all of these measures using Excel. So I have a data file. Let me get out to that data file. There we go. This contains the list of test scores from 25 students. One of the test scores is noticeably lower than the rest. It's going to be an outlier for us. All right, so let's look at how that affects our different measures. First, let's start by doing the mean. Notice that the data starts in A2 and goes all the way down to A26. So to get the mean, one way we can do it, type the equal sign and then use the average command and type in the data values, A2 through A26. I could also use formulas to do it. I could do sum A2 through A26 and then divide by the number of data values, 25. All right, now to do the median. We're again going to do an equals, and the word median opens up that. So again, we want to show the data values, so A2 through A26. And that calculates our median for us, or the midpoint. All right, to get to the mode, we would go mode dot SNGL A2 through A26. And there is the most common score that appears. All right, so if we look at these three results, the mean is lower than the median because of the outlier, but it's not by much. In this case, that outlier did not drag the score down a whole lot. But this is an example of why the median can sometimes give a more accurate summary of what is typical. Okay, to wrap up, the mean, median, and mode each offer different ways to summarize a set of data. The mean works best when data is symmetrical and clean. The median is more stable when the data is skewed or has outliers. And the mode helps us understand what's most common, especially in categorical or grouped data. Your job as a data analyst or a smart decision maker is to choose the measure that fits your situation and your data.